My name's Steve Williams. I'm the founder of KYANINGA Mobility, based in Western Uganda. Our major service gap in Uganda is we simply don't have enough therapists. Recently, the Ugandan government did a technical study on the rehabilitation, therapy and assistive technology, where it was found that Uganda only has 6% of the therapists required for the Ugandan health system. Of that 6% of the therapists that we do have, very few are trained in wheelchair fitting. Product gaps in Uganda are vast, ranging from crutches to wheelchairs. There are currently very few wheelchairs that are designed for the terrain in which we live in. So the terrain that we live in is full of potholes, dusty roads, stones, bumps. It's a very rugged environment. Now there are wheelchairs around the world that can fill this gap, but they're what we'd call off-road wheelchairs in Europe, in America. The problem with these chairs is they're vastly expensive, ranging from $3,000 to $8,000 a chair. So this doesn't solve the problem within Uganda. There is currently a large graveyard of imported wheelchairs within Uganda. A lot of these wheelchairs are manufactured in China and then brought over. They are initially very cheap to produce in China, but by the time they get delivered, they are relatively expensive for the product offered. The wheelchairs that are offered are rarely terrain suitable. They rarely are maintainable within Uganda. We have a lot of difficulty with the particular bearings, spare parts, the different alloys, so that they can't be maintained through the various welding techniques. So when we're looking to fulfill this product gap, we need to take all of this into consideration before we start the design process. At KYANINGA Mobility, we're an offshoot of our main organisation, which is KYANINGA Child Development Centre. KYANINGA Child Development Centre has 10 years experience working within Uganda in rehabilitation and therapy. We have a group of 80 specialists who work in physiotherapy, speech therapy, occupational therapy. We have orthopedic officers, nutritional specialists, epilepsy specialists. So through this vast network, we have sort of learnt the need that's required. And this has given us a great advantage for KYANINGA Mobility to start its design process. KYANINGA Mobility started with its design process looking at cost. The cost of wheelchairs is fundamental to the success. There is very little demand for wheelchairs in Uganda. There is just a vast need for wheelchairs. So we needed to look at what is the cost that an average person living in the village can afford a wheelchair, or do all wheelchairs need to be subsidized? Once we had decided to use bamboo as the fundamental material for the skeleton of the frame, we'd already realized the strength at which bamboo has in its raw form. But it's very difficult to join bamboo because you're joining two hollow sections together. We actually spent quite a bit of time thinking we could 3D print joints. We looked at having smaller metal joints to fix the joints together, but it either got heavy or unreliable, or we just couldn't get up to the standards that we required. So we ended up, which sounds very simple but took a long time, we simply took a piece of bamboo and we filled the end of the bamboo. And together with an engineer in Bristol called Clive Brett, we've been developing a machine that's going to actually take the measurements of the individual size of the bamboo, and then it will automatically cut the infill part. By filling the end of the bamboo, you haven't added much weight, but you've added enormous strength. You can now use traditional finger joints, webbing joints to fit the chair together. And we've done many tests now on this, and each joint can take over almost close to 200 kilograms per joint. So we hope now that we found the solution to the jointing problem. One of the design solutions that we've been working on, which is, again, it's trying to find a solution that's easy to maintain in Uganda, economical to produce, is an adjustability joint. So the adjustability joint is to allow the wheelchair to adjust, but also we want to be able to take the wheelchair straight. So we need it to be, adjustable, but we also, because we want this wheelchair to be taken apart and put into the local taxis, it can then be, the whole seat can come off, and then we can, take the chair and put it onto a local minibus. We can also then swap chairs, so you end up with a frame that's standard, but the chairs can be individually designed through either a specialty seating or a more standard seating. Also, the chair can be put into someone's home, because a lot of the clients that we work with have very small houses and can't fit the whole wheelchair in. Being able to take the chair off, we can put it on a stand and then they can eat with their families. As we discussed, most of the chairs built with bamboo, and we've tried to stick to the raw bamboo as much as possible, but for certain parts like the footrest, we needed to use laminated bamboo. It's incredibly strong, but there's a bit of a process. So first the bamboo is taken and then it's cut on a circular saw, and we create the strips from the raw bamboo. The bamboo is then taken, where the bamboo then gets planed over a surface planer. It's then edged, and then it's gone through the thicknesser planer. So you end up with these small pieces of bamboo, which are put together and glued in single layers. And then as the layers build up, you crisscross the layers to add strength, and eventually you end up with usable boards like this. So we can use this for the webbing for the joints, for the footrest, and then as we develop now into other products, simple walkers and standing frames, we'll be also using the laminated bamboo. We are currently refining a design that we use for the caster hubs. This is a local solution. Again, it's using motorcycle bearings that are available in any village in Uganda. The metal will now be slightly thinner, but this design now has been put on the testing rig and has done over 4,000 kilometers. So we're confident that we've found the solution. My personal connection with ISWP was started in 2018 when we were introduced to Dr. John Perlman. From there, we gained a lot of experience via Zooms and discussions, which ended up with an on-site visit. During the visit in 2021 to ISWP in Pittsburgh, we met a lot of Dr. Perlman's colleagues and the expertise that the university has to offer. We were welcomed with open arms. It was an incredible experience. We also got to visit some testing centres, and from there we started developing our own in-house testing, which has led to the change in the design and the development of our wheelchairs. The ISWP has helped us look at the testing side of our designs enormously. We've set up tilting tests, impact tests. We've got a carousel test that it's an old test, but they help us develop. As you can see from this video, this is a drop test that we're sort of a mix of an ISO test and a local test. As you'll see, we're just trying to see if the local wheels with the hubs that we put in will take an enormous drop weight. There's a 10 kilogram weight on this test, which drops down and eventually bends the hub of the wheel. Using local resources and the experience that we've gained from ISWP, we've put together a series of joint tests. The test that we are using here is a bamboo joint test. We've calibrated old engine parts and engine blocks that we can use for the weights, and we take each joint to breaking point and beyond, and then we use that data to reach the standards required. This is one of our tests that we were helped with ISWP. So it's an impact test that we do for each of the joints. So we've got a 20 kilogram weight in here. These are for the armrests. So we're now developing these tests in-house. This is our carousel test, which we got a connection through ISWP, who gave us this idea of a carousel test, which is developed by EvaCare. It's a great local solution to testing problems. Although we don't have all the machinery and testing equipment required, this is an inexpensive way to see if our wheelchair can get tested in its local environment, to see if the bearings last, if the tyres last, if our joints are strong enough. It's a general all-round test that gives it a complete overhaul to see what is going to happen. One of the ways we'd love to get more involved with ISWP is on our seating problems. The only foam available in Uganda really is mattress foam, which is very soft, really bad for creating bed sores. There is some foam that's sort of the offcuts they call chip foam, which we're making some progress with. We've started shaping our chairs. We're now developing on a more sort of developed shaped, but we're still very much in the infancy of the development of the cushions. We're trying to use 100% cotton for absorption, but also we're looking at what can be waterproof. So if there's more networking to be done, I think with ISWP on our cushion development. Another one of the opportunities that ISWP has given us was to organise a trip to join them at the WHO convention in Geneva, where we were very excited to get invited to the wheelchair guidelines convention, which has actually just been released a couple of weeks ago. This was an enormous opportunity for us to learn from the giants of the industry and what had already been accomplished over the years in Africa for the wheelchair industry. It would be great to connect to more of the ISWP network. We're still in the design development process. We hope to go into production later this year. If anybody would like to get in contact with us, we have our website, www.KYANINGAmobility.org. or please connect us through the ISWP contacts here at the event.